Good morning. Hi, I'm Mike Sharkey. I'm Director of Academic Analytics at University of Phoenix. Thank you all. I'm going to be presenting about a predictive model we did about trying to predict if a student was going to pass a class or not. Coworker of mine, Rebecca Barber, worked on it with me. She's actually has changed role. She's now with Arizona State University, so wanted to make sure Rebecca got credit. She was the getting the hands dirty statistician on the project. I'm more of the data analyst, tufty few paint pictures and tell stories, and she's the do the nasty, dirty statistics. I know how far my math major goes, and it doesn't go that far. So I want to make sure Rebecca gets credit for that. University of Phoenix, we're also part of the WCET PAR project, Gates-funded predictive analytics project. So I presented last year at LAK 11, presented this year. Really enjoyed the chance to collaborate and share. And what I wanted to do today is to share what we've done with our model, how far we are, and sort of almost validate some of that with folks here. I think on the EDM LAK conversation from yesterday, which was great, and they said the EDM folks think the learning analytics folks are too applied. I'm probably more applied than that. I really come at this of, there's been other presentations that I saw throughout these few days of, what does it mean? What are the actual impacts on students, and how are we testing it? One of the benefits we have is a large student body and lots of data to test things on. So, starting off, I am a data guy, and that's where I come from. So I've got to start off with not only the obligatory XKCD webcomic, but a very good one for data analysts. This explains why I was single throughout my 20s, because this is the kind of analysis I do. I looked in today, and there's actually another math one today about a student seeing her algebra teacher after 20 years and saying, haha, I never had to solve for X over the last 20 years. And he's like, why do people do that with math? You don't do that with cooking or other disciplines. So XKCD is always a good one to bring out. University of Phoenix, we are a private institution. We're much more akin to community colleges. We have adult, non-traditional learners, so we don't have residential. We are about 70% online, about 30% spread throughout 40 different states in the United States. A couple things that are very key. So one about our students are non-traditional. We don't have 18-year-olds living on campus. Another thing is we do centralized curriculum. So if there's an economics course, it was designed by academics, instructional designers, and subject matter experts out of Phoenix. And then whether you take that class in Atlanta or Massachusetts or online, you have the same core of that class. Faculty can change things and tweak things if they so choose, but the curriculum is developed centrally. And we have the adjunct faculty model. So our instructors are folks who have experience in their field. I teach for the university. I've been with the university for 10 years. I've been teaching for all of those 10 years. I teach once a year, so I don't consider myself a teacher. I do it. I enjoy doing it. I enjoy going through the process. It helps me stay fresh and understand our students and where they come from and what the data mean as I go and look at the data. So when we look at analytics and prediction, the question always comes up, let's use the data to predict success, predict student success. And I always come back, well, what is success? The model I use is as I've tried to answer more and more of these questions and fielded questions from deans, I come back to say, all right, well, let's talk about success. And to me, it's three orthogonal dimensions. The biggest one is learning. To me, it is the most important one, is can we predict if they are learning? Second one is progression. So are they making it through the system? And then the third one, engagement, satisfaction, right? Are they happy with their experience? And if you think about it, at least the way I put the model out, those are orthogonal. Somebody could learn everything they need to learn, but have a horrible time doing it. They could progress all the way through the system and not learn everything they were supposed to learn. So when people come down and say, hey, let's predict success, I try to engage a dialogue of what are you trying to do? Because these are very different things. They have different meanings and different impacts. If I'm talking to a business finance person versus an academic person versus an operational person, they'll have different assumptions about what success means. So last year at LAK, I talked about our back end data and where it all comes from. And very fortunate, we've done a great job of pulling data together for most of our or all of our students. And then the question is, what do we do with it? So in the prediction realm, with the folks that have done many other predictions, many similar predictions, I said, okay, there's a lot of work being done. Let's see if we can do the same thing here. I said, okay, so what am I going to predict? I have all this data. I have the capability to do it. Ideally for me, I would love to predict learning. Did the student learn what they're supposed to learn? Unfortunately, we don't collect data at that level, right? You have course grades, you have assignment grades. What we don't have is very good rubric level measurements of there are 4 objectives of this week or this part of the course that students are supposed to learn, and they learned 3 of them very well and 1 of them sort of well, right? That's really down to the rubric scoring guide level. We have plans for that, and I hope we get there. It's a bit of a brass ring from where I stand, but we don't have it today. So I punted on the first level and said, okay, I can't do that. Let me go down to persistence. All right, this is a survival analysis. If I can predict that moment, a student takes a course, they start a course, they drop out, realize at University of Phoenix, courses are taken in serial, 1 or sometimes 2 at a time in serial. So we don't have a semester-based term or a trimester-based term. So for us, this sequencing, the survival, is very significant for us because it maps well to our student body. So if I could predict that point where the student dropped out, that would be beneficial, because if I know what's going to happen, I could intervene and hopefully prevent it. Well, we know from talking to our students that a lot of the majority of the reasons for the dropout is life gets in the way. My kids are sick, I'm traveling with work, this didn't work out, my financial aid didn't go through. Now, there could be indicators of that and symptoms of that red event happening, but since a lot of it's personal, we don't collect data about how their children's health, I didn't think I could get close to predicting it. So I sort of punted on that one. I went down to the course completion. Can I predict a student will complete this course? That one I felt confident of. We have markers, we have prior demographics, current past courses, current course information. I said, okay, that's my research question. So the other thing to think out is, what do you do with the information? So as I sat down, I said, okay, if this is what I'm going to predict, what is my process to do all this? Well, the next thing is my other mantra of how I approach this is we take the data, we convert data to information, and then you put that information in front of someone who could do something about it, right? Very basic. Many people throughout this conference have said the same thing, either directly or indirectly. And then, this person who could do something about it is an instructor. They can obviously intervene with the student at that time. It's the student, his or herself, and many other things have put markers in front of the students, or administratively, a counselor, someone in the back who could intervene. And again, there's been models, South Orange Community College has done that, right, with different nudges for it. So this is sort of the model of what do we do with it. So having all these parts, I put the plan together, and it's this. Let's see if we can predict if a student's going to pass a class. Use all the data we have to create that mathematical model to do the prediction. Develop the model, and again, whether it's green, yellow, red, 1 to 10, create some sort of predictor, some sort of probability. Hey, a 10 means the student's going to pass this class, a 1 means they're pretty much going to fail the class. Now you have some sort of metric for all the students. And then the intervention for me is feed that to the academic counselor, right? If the academic counselor, if counselor has 100 students or 200 students on their roster, if they have a better methodology with which to approach them, it's going to improve things. And another salient point here is we don't have the answer. I don't know what that intervention is, right? That's always the thing. What do you intervene? Is it send them to tutoring or do this? We don't know. We can tell, hey, the model says it's because of grades or it's because of attendance or something, but the act of making the phone call and being that sort of personal life coach and just reaching out, the theory is that will at least do better than nothing. So I want to make very clear, this isn't saying, hey, we figured out what the problem is and what the remediation is for the problem. Our model is we already have these counselors. We have counselors that are already set up to talk to students. Let's make them more efficient at their job. They can better target who they call and with what priority, with what order. So here's the model. We had about 400,000 students, about 6 months or so worth of data. That was Over 1.5 million records we dealt with. These were all the students, and I think I did the last half of 2011 for University of Phoenix. I did it for all of our degree levels. I shouldn't say all, we didn't do doctorate, we didn't do certificate, non-degree. We did a naive Bayes model. I did done a first iteration with an outside consultant a year or so ago. We did linear regression. We had a really big sort of gray area. I'm not sure, like if the yellow light, right? We knew some greens and we knew some reds, but the middle was pretty large. Rebecca, who was doing the modeling, she was using SPSS and RapidMiner to do all the modeling. She went over to naive Bayes and thought we got a little bit of better accuracy out of it. And a couple of details about it. One, we had to split the model up into different pieces, different models. So looking at by program, right? Our associate students act very differently from our bachelor students and from our masters. Online versus classroom, we're about 70% online, 30% classroom, but it varies. Our associates program is online only, so that obviously there's one model. Week 0 versus week 1 or greater. So we did the model as a week 0 model, which is obviously very beneficial. Can I tell before that student even starts the class what my prediction is? And then week 1, 2, 3. And the next slide, I'm going to show the data that contribute. Obviously, as you go into the class, the grades they get in the class predict if they're going to pass. It's a tautology. If you're getting bad grades in week 1, 2, and 3, you're going to fail the class. So as you go on, that's the overpowering predictor of it. But in the first couple of weeks, it's very powerful. For us, our associates classes are 9 weeks long, our bachelors are 5 weeks, and our masters are 6 weeks. So we don't have a lot of time with which to say, if it takes 5 weeks to get an accurate model, our students are done by then. And so the more information we can get, the better. So I'm willing to take a little bit less accuracy for timeliness. Also, we split it by new versus continuing. New we did if you are within your first 4, 5, or 6 courses, it varied by degree level, because we know that our newer students act very differently from engaged students who have been here, right? Once you've crossed a threshold, 3, 4, 5 courses, you're stickier. You've been here, you're more committed. You come in your first, second course, and it's very different for those. Here are just some accuracy rates. So you can see we're well over 80% accuracy on predicting if a student's going to pass or not. So again, not perfect, but it's great for us to start. Here are the data. So these are all the elements. These are good predictors, okay predictors, and not non-contributing predictors to the model. I can go back to this slide. I know there's people interested in what's there. I love talking about this and sharing. We were talking with some folks before, and they said, data first course activity, that's not a predictor for you. I work on the PAR project with the folks from Rio Salado, and in their model, the data first activity is a big predictor. When is a student first getting engaged? Well, our policy is you've got to post your bio on the first day of class. So everybody posts within 1 day. If not, there's a tiny % who don't do it. So it's meaningless for us because it just goes away. So there's a lot of things that because of the policies, procedures, and the particulars of your program, that really changes, right? There is no magic indicator. I was joking with some folks this morning. It's shoe size. If we get their shoe size, that's it. That's the one thing that predicts everything. It really depends on your model and what comes out. So what do we do with this? So to operationalize this, we put it into our data flow. So the model here is student works in the system, data gets in system, flows throughout. We have a great engineering team that is sort of using some machine learning techniques and to take the data, embed that model inside the system. So we're not taking a fixed model that sits there. We can recalculate it, take those scores, put them into our CRM, our student resource management system. So now the folks, the counselors, can have a score on there and then create some sort of methodology for calling, right? If you follow, one model might be, hey, the 8s, 9s, and 10s are doing great, so don't worry about them. The 1s, 2s, and 3s, we maybe already lost, so let's focus on the ones in the middle that we can maybe nudge up. And then this is where we are now. And again, I tend to be very much on the practical applied side of things. So I look at this as a project, as a sort of not a research project, but an operational project. here are the steps involved, right? One, you've got to get the data, and I don't want to underestimate it. I've spent the last 2 years of my job working with our data modelers and getting that, and we're in a really good place. There's always more that I want, but we have a good start. 2 is do the math. Love the math, I trust the math, but it's very different from implementing it and seeing the results in the real world. So I've done the first 2, I'm at the pilot phase now. So now I'm working with the counselors to say, give me a controlled experiment. Give me 8 counselors, 4 and 4, right? They all have the similar kind of student, associates, same cohort, started at the same time. So something that is close enough to a control. Have one group do what they continue to do, whatever their current triggers and policies are for calling students. Have the other group use this number as a trigger with some methodology for calling, and say, do the ones using these data have a better job of retaining the students than the ones who didn't? So we're in that kind of pilot it and prove that it works now. So you know, I come here to talk and share, and I'm not going to sit here and say our model is awesome and it works great, because I can't. I'm not going to tell you it had X% increase in retention of our students. So for me, we're far enough along, but still not to where I need to be. I've got 5 more minutes left. I want to have plenty of time for questions if there are any. I'm heading to the airport after this to get through customs and catch my flight, so I'm not going to be around here after this. My email is there. Feel free at any time to contact me. I love talking and sharing, so please take that, and I'll take 5 minutes for questions.
Thanks very much, Mike. You're a brave man. In representing, as an administrator from a university, if I were to say that learning and progression are completely independent of one another, that students can get through a degree without learning anything as much as learning everything, it would be a very, very bold thing to say.
Do you agree with that statement, though?
Off the record?
Sure. It's just you and me. No, seriously. Do you agree with that orthogonal model that there's?
I don't think I really can.
Okay.
But I can see that students learn different amounts. There's no doubt, while still completing a degree or you know, reaching that completion stage. And so what you're doing, though, is in looking at completion, you're claiming then that it has little to do with identifying how much the students are learning. Is that true?
To me, that is the Better Business Bureau stamp of the accreditation, right? You got a degree, therefore I'm assuming you're a good employer, you know things. It's a bell curve, right? You know, for some institutions, having a degree from that institution, yes, means they are good. For other institutions, it means they made it through X years of their education. To me, I'm much more driven by skills-based. Right? I love Western Governor's model of competency-based. I know it's not perfect. I know there are holes in it, but I'd much rather see what you know than what the piece of paper says I think you did. So it's more of a show me. Again, there's a lot of details in there, the devil's in details, but I'm much more on, I enjoy the competency model. I think that's a better demonstration of what an individual knows. So
yet what you're researching here is nothing to do with competencies, as you claim. It has to do with basically being able to complete courses.
Absolutely.
Which has little to do with competencies, if that independence is truly
absolutely there. So again, if I had all the data, I would use this to predict, are they learning? But I don't have the data. So we have our own LMS, and what we're building into our next version is rubric level scoring nested into whatever assignment you want. Once I have that, I can get much closer at proving learning, and that's the first thing I'm going to do is once that starts rolling in, that's where I shift my model.
But not only are you making the claim that, or refusing to make the claim that completion guarantees that there's some learning has taken place, you're basically saying that it has no predictive capability at all.
I wouldn't say that. I say they're independent. I mean, can they be correlated? And yes, absolutely. But I don't want to totally say it's a separate thing.
Hi, Mike.
Hey.
Did you find that there was any differences in what data appear to be important in your week 0 predictions versus your week 1 predictions?
Yeah, you know, as you kind of go through, obviously once you get into the class itself, the current information, which is really just the scores earned in your current class, that starts to deafen everything else. It gets louder than everything else. A couple of those are really good, like the credits earned versus credits attempted. So you've taken 8 classes in the past, but only passed 6 of them. That ratio is a real good predictor. The main thing as you go through is just the the grades, the scores you've earned within your week 1, week 2 starts to outweigh everything else.
Thanks.
As expected. Yep. Hey, Chris.
I really enjoyed the presentation, and I want to take just a quick side to a step to the side. The Apollo group runs the University of Phoenix, and they also have these Carnegie intelligent tutoring systems. And we've been talking a lot at this conference about LAK versus EDM, and EDM is highly related to ITS, and we haven't traditionally seen a lot of ITS work here. ITSs often can measure some of that learning. Do you think there might be some synergies there? Do you see your work looking into that at all? I don't really know the relationship of the tutoring systems inside of the Apollo group with you, Phoenix, but I thought maybe you'd be able to share some insights.
Sure.
There.
So for me, having what the amazing work that the folks at Carnegie Learning have done, having that as part of our system, Apollo Group, is nothing but beneficial. So we've already implemented it in the math side. We're trying to now adapt it to the writing and grammar side of things. And that goes back to my same comment of learning, right? They get down to measuring learning. So when we piloted Carnegie Learning in 2010, I was doing all the data for it. And they have 94 markers, right? If you're taking their algebra class, adding mixed fractions, order of operations, and each one, they could tell you 1 or a 0. The student gets it or they don't get it, right? So now I have 94 different columns in my data for one math class to say, does a student get it or not? So to me, it gets down to that measuring learning. And again, that's really the direction we want to go. So we're very happy to be able to get their expertise. And the more we can use that kind of model, the better we are. One last one? Last one?
Besides data first activity in the course, did you guys look at any other use of the course management, learning management system, and see any correlations there?
So yeah, we included discussion activity. I think we included I have not as full clickstream as I would like, but did they open up materials? And those, what you have, discussion's a good example. Going back to my coming out policy, our policy for discussion is, at a minimum, you have to post 2 substantive things a day on 4 days out of the week. So guess what? Everybody's got about 8 things. So you don't get any variation in there for that activity. In our new system, we're going to get a lot better at clickstream tracking, so I can get much detailed activity, and I'll probably see much more dispersion there to give us some information. Thank you very much, everyone.